Hi, in this video we will learn how the inverse of the coefficient matrix of linear system can be used to solve that linear system. Well, we learned that a linear system can be written in the matrix form where we have a coefficient matrix times x equals to constant term vector. Then, if A is invertible, exactly the way we solve an equation, regular equation like 2x equals to 1, what we do, we multiply both sides by the inverse of this matrix, and while using the associativity of matrix multiplication, what we will see that this is A inverse times A, which is identity matrix, times x equal to A inverse B. And identity matrix times x is just x itself. So this way we solve the system. So the solution, so let me just write as a fact, if the coefficient matrix of a system, linear system, AX equals to B is invertible, then the system has unique solution given by A inverse. So let me just write x equals to A inverse B. Well, let's see this in an example. Paste. Okay. So we have this linear system. Let's first write its matrix form. So matrix form of this linear system is 2, 3, 1, 2. The variable vector is xy, or matrix is xy, and the right hand side is this. The coefficient matrix, we have to check if it is invertible or not. To check 2 by 2 matrices, if 2 by 2 matrix is invertible or not, we find AD minus BC, which is 1, and it's non-zero. Then this guy, as a result of this, A inverse, remember 1 over AD minus BC, interchange the entries on the main diagonal, multiply off diagonal entries by -1. So the A inverse in this case is this one. Well, then as a result, the system has unique solutions. System has unique solution, and it is given by x equals to A inverse times the constant vector. Here it is 2, -3, -1, 2, and you multiply to 1, 0. This will give us 2 and -1. And in this case, 2 by 2 matrix, the inverse is easy. If we later learn how to find inverse of other dimension matrices, and then you can do the same trick for the general linear systems. Example 2, find solutions of linear system AXY equals to 2, -1 if A inverse is given. So here, I don't know what is A, but at the end, we know that the solution is A inverse times B. And here, the A inverse is given, so we don't need even to find it. It is given 2 times that times 2, -1. This will give us 4 minus 2 and a negative 3. And that's the solution here. This trick can be used even in more general cases when you have matrix equation. So for example, this one, solve this matrix equation. Here, consider this as something like, again, 2x equals to 1. We have to check if this guy is invertible. This is invertible. Why? Because well, obviously this is 4 times negative 1 minus 3 times negative 2, and that gives us negative 4 plus 6. This is 2. So this is not 0, it is invertible. And we can find A inverse. A inverse is 1 over 2. Swap the entries on the main diagonal, multiply entries of diagonal. So this will give us negative 1 over 2, negative 3 over 2, 1 and 2. Then the solution here is that you multiply both sides by negative A to the A inverse. So A inverse here times 4, 3, negative 2, negative 1, x equals to, we are multiplying from the left. So you have to multiply in both sides from the left. And here 1, 0, 2, 1. This is A times A inverse, so this would be identity matrix times x is equal to, we have to multiply this negative half plus 3. This will give us 5 over 2. Negative half times 0 plus 3 over 2 times 1. 1 times 1 plus 2 times 2 is 5. And this guy 1, this is just 2. Well, identity matrix times any matrix, well, if the dimension is consistent, if you can multiply, then it is x equal. So you see that this trick of that we saw for this very easy case, multiplying both sides by the inverse of the coefficient of the variable, is the trick we can use to solve system of linear equation with invertible coefficient matrix.